Look at a straight road, not just any road, a long one, stretching far into the distance. As it moves away from you, it seems to narrow until it eventually disappears into a single point. Now pause for a second. Is the road actually getting narrower? Of course not. If you walked down it, the width would stay exactly the same the entire way. So why do your eyes insist that it shrinks? That question sounds simple, almost childish, but hidden inside it is something much bigger, because this isn't just about roads, or drawings, or art. It's about the fact that your eyes don't show you reality. They show you a version of reality. And that version is built on something called a visual perspective. By the end of this video, you'll understand why perspective exists, how it works, why it looks so convincing, and why it lies to you constantly, without you ever noticing. Let's see something similar. Objects do not get smaller when they move away from you. Your phone doesn't shrink when you place it on a table across the room. A car doesn't physically compress as it drives down the street. Yet visually they do. So what's actually changing? Stay tuned to have a clear answer for such phenomena once and for all. The art of perspectives was invented during the Renaissance. Before that, people were not aware of its existence. Look at ancient art, Egyptian murals, medieval paintings, early symbols. People look flat, buildings feel stacked, important figures are larger than unimportant ones, even if they're farther away. For a long time, people assumed this meant ancient artists were bad at drawing. They weren't. They just weren't trying to recreate vision. They were communicating meaning. Size meant importance. Precision meant hierarchy. Depth didn't matter. Perspective wasn't missing. It was ignored. But eventually, artists became obsessed with a new idea. What if art could look like reality? During the Renaissance, artists faced a problem. They wanted to show depth on a flat surface. But how do you show something that doesn't exist physically? So they studied vision itself. They noticed something strange. Parallel lines, lines that never meet in real life, appear to meet in the distance. Train tracks, roads, hallways, they all collapse into a single point. This point became known as the vanishing point, and with it, one-point perspective was born. One-point perspective works beautifully in very specific situations. Looking straight down a road, standing in a hallway, facing a flat wall head-on. All lines move toward a single point. The image suddenly feels deep. But there's a problem. Humans almost never look perfectly straight. We turn our heads, we stand at angles, we move through space. So one-point perspective often feels stiff or artificial. To fix this, artists needed another trick. Stand on a street corner. Now the world doesn't shrink toward one point. It shrinks toward two, one down each street. This is two-point perspective. It allows objects to exist in space, not just face the viewer. Boxes look solid. Buildings feel grounded. Scenes feel more natural. But even this still isn't enough, because sometimes depth doesn't just move sideways. Sometimes it moves vertically. Look up at a skyscraper. Notice how the vertical lines don't stay parallel. They converge. This is three-point perspective. It adds height to depth, and psychologically, it does something powerful. It makes things feel massive, dominant, overwhelming. This is why filmmakers use it constantly. Heroes shot from below feel powerful. Villains tower over the frame. Falling scenes feel dizzying. Your brain associates converging lines with scale. With three-point perspective, you can create images that look very real, since we live in the space with three spatial dimensions. Creating perspectives with three perpendicular vanishing points create a very realistic image. When we try to clearly answer why perspective exists, we realize that the reason is none other than our eyes. As you know, our eyes are roughly spherical objects that have a transparent fluid inside through which light can reach the retina located at the back. Your eyes also have crucial parts that are very important for perspectives. These are called lenses. These lenses are called convex lenses, which means they cause light rays to converge into a point. When you see anything, whether a beautiful landscape or an object near you, all the light rays from the scene will first reach to your lenses and get converged and reach to the retina of your eyes. The amount of space you can see at a time is limited. You can call these spaces your cones of visual field because from these space light will reach your eye. When you see a straight long road it appear to converge to a point because from all the points in the scene light will reach your eyes. Now imagine there are buildings to the sides of the road. Here is the interesting thing. The buildings in the scene of the road that are closer to you will reach your retina at the lateral ends but will take significant portion of your visual field. However, the lights from buildings that are far from you will reach to your retina at around the center but will take only a very small amount of area in your retina. The further the buildings are from you, the amount of space they get in your retina will diminish. As you know, small objects can fill your visual field if they are closer to you. However, you can clearly see long mountain chains if they are far enough from you because of the area covered by your cones of visual field keep expanding as they move farther from you. This is why they will create the illusion of converging to a point. The same is true for two-point perspectives. When you look at a building from an angle, you will clearly see a two-point perspective because the lines of the building seem to converge into two vanishing points, one at the left and the other at the right. The reason for this is not different from the one-point perspective. The part of the building that is closer to you look bigger, so get larger portion on your retina. However, the parts of the building that are farther from you will keep getting smaller since your visual field can cover wider area. The same is true for three-point perspective except for the fact that it add one more vanishing point at the top. The other things that use perspectives are cameras. Images of a camera respects the principles of perspective. This is because they work almost exactly like how your eyes work. The other organ important for processing a visual perspective is your brain. As you know, the significant portion of your brain is dedicated to processing visual information. This includes perspective. Your brain gets lots of information from the images created in your retina. For example, scenes that are far from you look small. This is processed in your brain. After all, the purpose of your eyes is just to transfer visual information to your brain. It is the brain that do the final work of reconstructing the scene from the image it gets from the retina. So perspective is not truth. It's not reality. It's a compression algorithm, a way to flatten a deep, complex world into something your brain can process quickly. Artists didn't invent perspective to copy the world. They invented it to copy how humans see. And that distinction matters, because once you understand that, everything will be clear and obvious. If perspective can change how you see space, if it can shape emotion, scale, and meaning, then maybe perspective isn't just visual. Maybe it's cognitive. A reminder that what feels obvious, what feels natural, what feels real is often just one way of seeing. And sometimes the most important thing you can change is not what you look at, but how you look.